right. Marker, okay. Precision, this one you should know is 1 millimeter. And so the uncertainty would be half a millimeter. Oops. Half a millimeter. What's that? 1 centimeter. You could do 0.1 of a centimeter, a tenth of a centimeter. That's fine. Yeah. Oh, yeah, because I showed you the counting, right? Yeah. So if you did that, if you went 0.1 of a centimeter, and the uncertainty is plus or minus 0.05 of a centimeter, yes. Yeah, you're good. So when it comes to measurement, I should be doing closing the blind. Thank you very much. Okay, so this is how I will treat it on the test as well. 1 mark for the precision, half a mark for the uncertainty when it's like this. So you can still score half a mark if you divide whatever you determined as the precision. Okay, so 1.5 each of these. Here, what are we at? 16, right? Because it's 8 to here, another 8. So it would be 1/16 of an inch. I may not have said this before, but feet would be 1 mark, right? Inches, 2 marks. Have you ever, I'm sure quite a few of you know this, right? But if it ever shows up like that on, I think the back side has feet, inches, right? 1/16 would be 1/32 of an inch for your uncertainty, which if you rather do decimals, that's your precision, that's your uncertainty. So one for the precision. If that's wrong, you lose a full mark. Half for that. And on the test, I'll be very picky with rounding. Do not round, and do always include units, especially in this unit. I mean, it's always the case, right? Which one do we do next? This one. I'll do C. 1, 2, 3, 4. Another 4, so that'll be 1/8 of an inch. So that'll be 1/16 of an inch for my uncertainty, which would be 0.125 of an inch, or for uncertainty, it would be 0.0625 of an inch if you divide that in half. Yeah. Okay. This is nothing. We're just, anyways, yeah. Okay. Mm-hmm. I got the denominator for uncertainty, but I put the 2 instead of 1. So I got 2/16 instead of 1/16. Which is still 1/8. 2/16 is 1/8, right? Yeah, I would say take off half a mark. Next, the beaker here. What are we going up by? 50, right? So it's 50. See, here you would see a lot of common pictures. I have a software that can change these quite easily. So on a test, be careful, right? So do your large minus small, right? Divided by gaps, whatever you need to do to figure that out for sure. Don't guess, okay? I said this once, I'll say it again. If you ever have a gauge like this, right, and it's like it goes 50, 60, 70. Sometimes students are like, whoa, because there's like a little dot here where this gauge would rest. So they're like, oh, it's 50. No. Look at what you have. Ignore what's before. So it's the precision within the numbers that are there. Okay, don't start making stuff up. Okay, so this would be plus or minus 25 milliliters. 1 for the precision, half for the uncertainty. Okay, let's go up here to the thermometer. What is that? 1, 2, 3, 4, 5. So that'd be 50 divided by 5 is 10, right? So that'd be 10 degrees Fahrenheit, and that'd be plus or minus 5 degrees Fahrenheit. And the plus or minus is optional. That's what the province says when it's standalone, but if it's measurement plus or minus uncertainty, you have to have the plus or minus. Yeah. You have to have Fahrenheit, yeah. Fahrenheit. Half a mark. Once. You don't lose it for every. So in this question, I would just take half a mark once. First page, 1, 2, 3, 4, 5 times 1.5. That'd be 7.5, right? The first page is worth 7.5. Backside. Please don't leave these blank, right? Define tolerance using your own words. You can give a specific example if you want. So you can say it's the range of acceptable values, right? It's the range of acceptable values. Comma, so that the part is still usable or can be used for its intended purpose or something like that. You can say it's the variation that is allowed so that the part can still be used for its purpose. You can say it's the largest and the smallest acceptable value, something like that. Yeah. Workplace? It doesn't have to be workplace necessarily. It has to just be whatever industry, whatever you're in. So 2 marks for that. Any questions for that one? I did highlight a few things on under tolerance. You look it up. In example, you could say, right, for example, the temperature of produce, right? If it's too high, it's going to spoil. If it's too low, it's going to freeze, right? If you have lettuce and it freezes, you can chuck it, right? It's no good, right? Same with tomatoes and stuff like that. In each case, state the nominal, minimum, maximum values. What is missing there? Tolerance, right? Okay, whatever. It's all right. Next time. So the nominal, I'll just show you here. This is the key. Ready? So the nominal is always the front number, right? That's not to be debated. It's the first number is always when it's there. There's one case where it's not there, right? When it's the max and the min. So I would say just check. Yeah, do a quick check. I would say this. If you make one mistake in this first row, take off half. If there's more than one mistake, then you lose the full mark for that because each one of them is worth a full mark. So one mistake, you still get half for that row. More than one mistake, you wouldn't get any marks. Yeah. That's okay. Let's say moving forward, we are going to stick with the decimals that are given, right? So we're assuming this device can measure up to 4, like that fourth decimal. So that's why I do it in this, especially in this unit. But that's okay. The province would be okay with that. And then look at D. D has a plus and a minus. Usually one of them is 0. This is yesterday I did tell you about the curveball, right? But it's really, if you just follow, you add it to get your max, and then you subtract these two to get your min, right? Just like that. And every single time you could find the tolerance by just subtracting the max and the min, right? That would be your tolerance. I don't know why I didn't add it, but That's still expected. Okay, so get a total out of 5 in this section, right? So if you got every single row correct, then it's 5 out of 5. But again, right, let's say B, you made one mistake, take off half. If you make more than one mistake, then that whole row gets a 0, okay? And you should have units, everything there. And the last one I'll do with you. Okay, so here it is. Notice that the half is missing, right? So if I tell you that it is a tolerance, then if the half is missing, not a big deal. You don't have to worry about dividing it in half. On the test, I'm quite certain that every single time there's a half in front, right? The reason why I like to leave the half in front, because uncertainty, right? Remember when it's measurement and uncertainty, this looks more like that. I like to differentiate between tolerance and that, but I tell you that this is a tolerance so that you don't have to guess, right? So anyways, what I would suggest, okay, when you have one of these, when you have a tolerance, you do what I got you to do yesterday, min or max min, tolerance, and nominal. You do that on the side, regardless of whether or not I ask for it, right? And then you go this plus that gives you 68. And then this minus that would give you 67. The tolerance is 1. And the nominal is that first number, 67.5 millimeters, right? So once you have these 4, you're good to go, right? And then make sure you have these on your study sheet, the four ways of doing it, so that you know when I ask you, state it in the other 4 formats, right? If it's like this, just state it like that. If it wants it like this, you get your max, right? Plus 0 millimeters minus whatever the tolerance is, which is 1 millimeter. And then this one, you grab your min, minus 0 plus tolerance, which is 1 millimeter. So these are all saying the same thing, right? They're all saying the same thing. So 1 mark for each correct. And this is how I do it. If you make a mistake here, you are probably going to lose a full mark. And then I honor what you have here. Like if you use this stuff to come up with these, then I will still give you 2 marks, 2 out of 3. Question? At the 0, but there's one at the 1. I think I'll be okay with that. No. If you get this right, you get 3 out of 3. But if you do this table on the side, and let's say you make a mistake here, I would go -1 here. But then I'm assuming, right, you're grabbing your numbers from that table to make this. You would still get 2 out of 3 if this is done correctly, if you grab the right numbers from your table. So I think you have a bigger chance of scoring partial marks if you do this versus if you just get everything wrong. I don't know what you did, right? I think I just wanted to say one thing here about, let's talk, this is just a teaching moment, so let's add it up first and then we'll do that. So 2, 5, and 3, 10. 10 for this backside, okay? So 10 and 7.5, so 17.5 is your possible total here. 17.5, right? Just weird, but we'll stick with it. Question? 17.5, yeah. Don't pass it forward yet. I'm not recorded, right? But anyways, see, that's why it's good to be in class. So pass it forward. And if I tell you that the something is measured and it's 4.0 0.05 meters, but it says that it's the ruler that was used to measure this was marked in quarter of a meter. Like if you see this, you know how you are always, when I just give you the number, you get your precision just by looking at that number, right? But if you see anything like this ever, this piece was measured with something that has increments of quarter of a meter, or it's marked with quarter meter increments or something like that. This always trumps everything. Okay, when that is mentioned, or if you have a picture of that measuring device, you go by it. You don't go by the number. That's very important to keep in mind. So if there's nothing else given, then you need to just say this one is 0.01, the precision. But other than that, you go by the markings. Okay, so okay, follow. Yeah. You put 0.5, so that'd be a -1. This is half. So if you divided so this will actually not be worth 3, this will be worth 4.5. Because I figured that it's you get too many freebies, right? If you get the precision wrong, as long as you divide it by 2, you would get half of the mark, and I think precision is the most important one, right? So I'm changing that up. Here it's the second decimal, so it's going up by 0.01. So this is your precision, uncertainty. Third decimal, 0.001. So there's 0.0005 there. So is this kilograms? Sorry. See, you guys are the teacher now. That's right. That's right. Get it right. Get it right. It's not even the same, right? We're not even measuring mass and length, right? What's going on here? Next, to figure this one out with its uncertainty, I recommend going through the motions just like you did before, and then you take these two, write it like that. But if you didn't do it and it's right, you still get 1 mark. But you're playing with fire, right? Some of these are very similar to what you've seen before. I know it. I know that, right? That's okay. Oh, this is wrong. This is this is actually wrong. Because I checked with the province, and I did this before, right? So it's precision is actually quarter of a foot. You can go a quarter of a foot like that, or 0.25, and then split that in half and get 0.125, right? Or 1/8. Is that? If you did it like I had it here earlier, that would not be correct. So we will go -1 because I did this before. Yeah. What did you put down for units? Inches? Yeah, half off. Half a mark. And so yeah, I always check. There's actually a person you can email at the province, and I was never sure because I told my students, hey, if you struggle with decimals, do this. But then they say that technically this indicates that precision is a quarter of a foot. So you have to go like this and then like this. So I had it wrong earlier. Okay, good thing that we checked this. Next, here, the third decimal, even though it's a 0, that's where we zone in on, right? And I'm missing my units here, but technically this is my final answer here. So 1 mark for that. and then seconds, right? It's to the nearest 0.1 of a second, right? This timer you're using, if you stop it, it's like, hey, the assumption is that it's going up by 0.1 of a second. So that's my uncertainty. So I can state that time. You don't need to convert to seconds, right? Like I've seen that on the previous AC. You don't need to do that. Just stick with that. And here there's 2 zeros, but this is assuming that this is going up 0.1 or down 0.01. Sorry, 0.01 up or 0.01 down. So that's my uncertainty. So I can state that measurement like this with its uncertainty. And this one I will do with you. Okay, so let's first and foremost make sure you add this up. You get 5 if it's exactly like this. And if you missed some units, I would say for this question, just half mark once. But on a test, I will be a bit stricter with that. Okay, so here is combined. This is combined uncertainty, okay? Things pile up. So it says calculate what? The maximum and minimum lengths of these pieces. So you need to go way back. You need to actually go, okay, I'm welding them together. So I'm going to figure out the precision and the uncertainty of each piece. So the 3.2 has a precision of 0.1, uncertainty there. And then you have that other piece, we're assuming the precision is 0.01, the uncertainty is 0.005. You're following, right? They're not all the same. Then the last piece is just 4 feet flat, right? So the precision is 1 foot, which means the uncertainty is 0.5 of a foot. And so then what you should be doing here is add up all those pieces. If you add that all up, you get 9.95 feet. Forget about the precision, but you're going to add up all the uncertainties, and it ends up being 0.555 of a foot. Since this is basically, unless some of you probably can do this in your heads, I couldn't, but this would, for me, in my opinion, this would already give you 2 marks, because you have to do a lot of work to get there. Next, the maximum and minimum. Just follow, guys, okay? Lots of time to talk later. Max is adding these up, so that would be 10.505. And subtracting these will give you the minimum, which is 9.395 feet. So I would give you a mark for that, because that's fairly simple to do once you have everything else. So in other words, if you have these two showing up as your max and your min, you get 3 out of 3. It doesn't matter how you did it, you get 3 out of 3. So let's do some backwards, like what happens if? What happens if you, for example, got one of these precisions wrong? It means your uncertainty is wrong, right? We'll just go -1. Like if you make one mistake here, we'll just go -1. So you'd still get 2 out of 3, provided you do everything else right. I would say make sure you tell me which one is max and which one is min. Don't just have 2 numbers show up, right? I need to know exactly. And so that's how I would mark it. So give yourselves a mark 1, 2, or 3 out of 3 today. You're the teacher, right? Next. This is the last one we will have time for. There's a 2.43 meter piece of trim. Trim is like at the bottom of where the floor meets the wall. You need to cut off this much for it. It's 2.43. The precision is 0.01. The uncertainty is 0.005. You're cutting off. Shh, pay attention, okay? Precision is the same, right? No, it's not the same. It's 0.1. Uncertainty is 0.05. When you cut that off, you get 1.93 meters. Plus or minus, what do you do with uncertainties every time? You add them. Yes. 0.055 meters. And what does it say? Max and min. So the longest possible piece you can get is 1.985 of a meter. The lowest is 1.875 of a meter. So here I would give you 1 mark for this piece and 1 mark for getting the max and the min. Would you like to keep this one? You get to keep this one. Let me see here.